So here we go with lesson 16C. In lessons 1, 8, and 16, you submitted data about the number of hours you spend working on math homework outside of class, alone, and with others. So number 1, think about the amount of time you spend outside of this class each week working on course material. Include tutoring, group work, time you spend studying alone, and any other work related to class. Has your time or has your study time changed during the term? You'll have to answer that. Part B, make a hypothesis. Do you think people in this class are studying more or less outside of class as the term has gone on? And then part C, do you think there's a relationship between the time spent studying outside of class and the course grade? So something along, if we're looking at an X and Y axis, the hours you spend. Why is this writing sideways? I'm sure. Let's undo this. So the time that you spend, the hours that you spend outside of class, like 1 hour, 2 hour, 3 hour, etc., 4 or 6, do you think it has a relationship with your grade? Like whether your grade is a 50 or a 60 or a 70, etc. So this is a great time for some self-reflection on has your study time changed? And it's also a great time to think as we head into test 4 and the final, how that time can increase to make one last push so that you can pass this class for the semester. So answer these thoughts for your own personal reflection, and then join me on the objectives. The objectives for this lesson are to understand the usefulness of grouping data to look for patterns, the impact of your study time on success in a math course, in actually any course and in anything in life, the amount of time you invest, a quality time, should have an impact on the results of the event or activity. And we're going to be able to use a spreadsheet to sort specific information to analyze and to graph. We can use a spreadsheet to build a stacked column graph, and we can analyze data and the related stacked column graph to make some conclusions about the patterns that we're seeing. So in this lesson, we're going to analyze our class data to understand how time spent studying for this class has changed probably, possibly, or hopefully over the term, over the semester. This data set contains information about hours spent in this class, outside of class alone, and with others from the first week and lesson 8 and lesson 16. We're going to group, or what we call aggregate, the data and make a stacked column graph showing the data over these 3 time periods. So looking at question 2, what we have, it says to open the spreadsheet of your class member's study time, inspect the data, ensure that you understand what you see in the columns. So what I have collected, it's from some of our 2 online classes and from some of my class today, my Monday, Wednesday, Friday class, and I've put the data in a spreadsheet. And so this is what I have. The number of hours per week studying with others, studying alone, and then a combination. You'll notice this is from week 1. I took your information from week 13, put it here, hours studying alone or with others and alone, and then the total there. And I made sure that I have the right person. In other words, this person who had 2 hours, which is 4 from week 1, they're now 0 and 2 at week 2. So part A says, looking at all of this data, looking especially at columns C and G, do you notice any patterns? Oh, goodness. And it just looks pretty haphazard. And I've duplicated these columns over to the side. These are still the total number for week 1 and total number for week 3. And when you look at these, it just looks like you could find like the largest or the highest numbers, the lowest numbers. But what they're trying to ask us and to explain is that it's not really clear, there's not a good pattern. We need to organize the data and present it in a graphical display. Part B then tells us, Part B then says sort the data, ascending to descending, and it gives us some directions on a dialog box, etc. It asks us to sort this data, and then on part C to make a table that aggregates, puts the data together, the total number of hours spent studying outside of class, and that's a combined, alone and with others, into 3 categories. They're asking us to sort it 1 hour or less, and I didn't do it for every. I just did a total right here where it says outside of class. Students didn't spend 1 hour but less than 3, and then the students who spend more than 3. And for each week, they're asking us to sort it, make a table, and a course that meets 3 hours per week should look similar to the one that is presented below. So this is what I did. Ours would be from the week 1. I don't have lesson 8, but I have from week 13 and the percent at week 13. So I did make this chart. It asks us to calculate percentages. Do you see any patterns? Let's use a spreadsheet feature, do the 100% stacked columns, and then finally use the information to write a description of how study time of the students in the class has changed as time has gone on or the term has gone on. Use quantitative information in your statements, and does the information in the chart match your hypothesis about student work? So we assume that you may have one thought about studying at the first of the semester, and then as you get into the details of the course, it is very likely and kind of expected that your study time will increase. So right here, oh, and I can't write on this one, but right here, you'll notice at the top, you'll notice over here where the hours are, the less than, the 3 to 9, and the greater than 9. And then I went through I couldn't get my sort feature to work, so I just counted. And I looked for the less than 3 hours. We had 1 person in our list, 20 who were 3 to 9, and then 5 who were over 9. And this was in week 1. I did the percentages. So 1 divided by 26, that's about 4%. Then about 77%, then about 90%. And I double checked and we came out to 100%. So then I did the same thing for week 13. We have 3 students who are less than 3 hours total combined outside the class. 11 students who are 3 to 9, and now we're at 12 students. And right here is a big jump. We had 20 who were studying 3 to 9 at the first of the semester, and now it's just 11. But then here we only had 5 over 9, and now we have 12 over 9. I took this information, I went up here to insert and grabbed actually what I grabbed. I grabbed columns B, D, and F. And then that gave me these beautiful labels at the bottom. I typed in the title, Study Hours for Fall of 2018, and it does go up to 100%, and you see our stacked columns. So week 1 was very small on less than 3, and it grew a little bit. So some of the people in the higher hours went down here to the lower hours. We have a very large middle, which is represented up here by this 20 hours on week 1. And then these two are kind of tied, but it asks us, it says on part F, now, nope, it asks us on part G, use the information to write a description, use some quantitative information, and then does this match your hypothesis? I would assume your hypothesis would be that people will study more as the semester goes on, but whatever your hypothesis was, let's look and compare. And so if they're asking us to use quantitative information, practice writing 2, 3, or 4 sentences. Like number 1, you describe what you see. And you can make a sentence like, for week 1, the students in the Math 1332 class studied, we had 1 student who studied less than 3 hours, 20 students who studied between 3 to 9 hours, and 5 students who studied greater than 5. That's a great sentence right there. Week 13, we had, and you could mention 3 students who studied less than 3 hours a week outside of class with others and alone. And then you can say the same thing here. We had 11 who studied 3 to 9 hours, and 12 students who studied more than 9. There's a second sentence. You're using quantitative information. Then you can even talk about the stacked column graph. And you can say that noticeable changes were, well, before that, you can talk here about the percentages. You can talk about how the less than 3 hours went up. You could do a relative change if you would like to, an absolute change if you would like to add more depth to your comments. If you want to just look at where it is right now, right here we had 76% of the students that went down to 42%, whereas this 19% went up to 46%. You can write a sentence about that, or you can just focus on the middle, the 3 to 9 hours. You can focus on specific parts, but you're a reporter, so tell what you're noticing. And then I would write something about the stacked column graph. And for me, the most noticeable change would be that this middle group in week 1, to me, has drastically reduced. And then the higher group, the 0 to 9, greater than 9 hours, has increased. And you could say drastically increased, somewhat increased. But even though in the end they're very, very similar, the switch is pretty drastic. So you can easily get 3 to 4 sentences out of this describing the data, talking about the results, and then just honing in on something that is of particular interest to you. So then it asks us a question about how does your class data compare to a question in the preview assignment. We're not going to look at that, but I do want you to answer question 4. Question 4 says to talk about the advantages and disadvantages of a stacked column graph. Part A, is a stacked column graph a good tool for the display for this data? Why or why not? And if you were listening to me do lesson 16B, it's kind of a struggle to try to interpret and read and draw lines across to see how tall the stacked parts really are. So to me, that's a disadvantage. Sometimes it's hard to read, but if you're looking for a quick visual, that is an advantage because you can look at this orangey looking color and go, wow, something changed from week 1 to week 2, and then you can investigate it further. Some things you might say is, I like the graphs because it's easy to see the comparative size of the bars. Yes. Or you might say, I don't like column graphs because it is just really difficult to estimate the percentages. Yes. And so then question part B says, what other kind of graphical displays could you use? And we could easily convert this over to like a side-by-side column chart where you're looking at these by week. We could do a myriad of other things, like if I go ahead and just click on this information, and this information, and I'm just holding down the control key, go to insert, go to charts, and a lot of different things pop up. Like this one was one they mentioned, looking at the side by side, like week 1, week 2 on the hours. You could go horizontal, you could go stacked area, lots of different things. We can do all charts. We can just keep going on this. We can make 3D charts. It's endless. Bottom line is, what kind of presentation are you doing? What information are you trying to convey clearly to your listeners? And this is definitely a way or a form of a graphical display that you should be familiar with and could use in presentations and in class projects in the future. This ends lesson 16C. Go look at your syllabus, see what's going on, make a decision, and I'll see you in a future video. Bye-bye.